During the course of this video, I'm going to go through each of these reactions that you're going to see in the Test 3 portion of the Blue Book, Problems Test 3 file that's in your Test 3 folder. And what I'm going to do is I'm going to classify each of these reactions as either acidic, basic, or neutral, or oddball. Now, the acidic, basic, neutral mechanisms I explained in a previous video. These are the common mechanistic patterns that will cover about 90% of the reactions that we're going to go through right now. The other mechanisms are considered oddball because they don't fall into that acidic, basic, neutral category. And some of those will be oddball, but most of them will be acidic, basic, or neutral. So let's start, and we'll start with the top one here, oxidation. That's going to be an oddball. The Grignard reaction, it's oddball slash basic. Anything with acid or base written next to it is either going to be acidic for acid or basic for base. So a lot of these do have acid and base written next to them. Acid chloride hydrolysis here, though, that's going to be neutral. Now, what classifies this as being neutral is the fact that there's nothing on the arrow that's positive or negative. It's just a neutral thing here. And what classifies this as being acidic is going to be the H+. What classifies this as being basic is, in the first step, something negative being present. So you can see anything with acid or base is going to be acidic or basic, as I said earlier. Thionyl chloride, that's going to be an oddball. In the synthesis of acid anhydrides, this first step with the carboxylate anion formation is oddball. This step here, where the negative charge comes in and kicks out the chlorine, that's going to be considered a basic mechanism. Methyl esters from diazomethane, that's going to be oddball. Acid chloride plus alcohol, that's going to be neutral. Esterification is going to be acid, that's because of the H+ here. Lactone formation, that's going to be acid as well with the H+. Lactone formation and ring closure, this is going to be one of your mechanistic questions in Test 3. This is going to be an acidic type mechanism. Synthesis of amides, that's going to be acidic. You can see the H+ there. The reaction of acid chlorides with amines, that's going to be a neutral type reaction. Lactam formation, that's going to be acidic. Synthesis of nitriles, that's going to be oddball. Dehydration to form nitriles, that's going to be oddball as well. Reactions of acid chlorides, the hydrolysis, this one's going to be neutral. Reaction with amines, that's going to be neutral as well. Diabel, that's going to be a basic mechanism. Reactions with alcohol, that's going to be neutral. Organocopper lithium reagents, that's going to be a basic type mechanism. This one here, the hydrolysis, will have an acid and a base. Esterification, we have an acid and a base. Amidation, that's going to be acidic. Reactions of esters, we have an acid and a base. Transesterification, we have acid and base. Amidation, that's acidic. Reaction with Grignard reagent, I'd classify that as being basic or partly oddball, but generally basic. Ester reduction, I call that basic as well, basic or oddball, but generally basic. Lactone hydrolysis, we've got an acidic and a basic mechanism there. Lactone transesterification, acid and base. Lactone amidation, that's going to be acidic. Lactone with Grignard, I'd call that basic slash oddball. Lactone reduction, I call that basic slash oddball as well. In the case of reactions of amides, we have an acid and base. In the case of lactam hydrolysis, we've got acid and base as well. Hofmann degradation, that would be an oddball. Reactions of nitriles, these are acidic or basic, but they do fall under a slightly different category, so I'd call them acid slash oddball or base slash oddball. They do have acid or basic elements to them in accordance with what I've set forth earlier as an acidic, basic, or neutral mechanism. And this last one here, the reduction, that's going to be an oddball as well.